Glucose. In this module, you will learn about glucose. Glucose is a monosaccharide with the molecular formula C6H12O6. We all know glucose as the most common and abundant sugar. But the compound we are referring here is actually one of the stereoisomers of glucose. Its correct name is D+ glucose. It is also called dextrose. A molecule of dextrose has an open chain structure as shown. It has a chain of 6 carbon atoms in which the first carbon atom has an aldehyde group. Each of the other 5 carbon atoms of the chain has one hydroxyl group. The remaining valencies of the carbon atoms are satisfied with hydrogen atoms. This structure clearly shows that dextrose is an aldohexose. In other words, it is both an aldose and a hexose. An aldose is a monosaccharide with an aldehyde group in its molecules. A hexose, on the other hand, is a monosaccharide with 6 carbon atoms in its molecules. This structure of glucose is evident by many of its properties. For example, when heated with hydrogen iodide, glucose forms N-hexane. An N-hexane molecule has a straight chain of 6 carbon atoms, and this indicates the presence of the same in a glucose molecule. The reaction of glucose with hydroxylamine forms an oxime, whereas that with hydrogen cyanide forms a cyanohydrin. These reactions are characteristic of carbonyl compounds, thus confirming the presence of a carbonyl group in glucose. Also, glucose, on reacting with a mild oxidizing agent like bromine water, oxidizes to gluconic acid. Gluconic acid is a carboxylic acid with 6 carbon atoms in its molecule. This suggests that the carbonyl group present in glucose is an aldehyde group. Besides, glucose reacts with acetic anhydride to form glucose pentacetate. The presence of 5 acetyl groups in the product indicates the presence of 5 hydroxyl groups in a glucose molecule. Further, the high stability of glucose suggests that these 5 hydroxyl groups are attached to 5 different carbon atoms. Many other properties of glucose were studied by the German chemist Hermann Emil Fischer, who gave the spatial arrangement of the hydroxyl groups of dextrose. Now, in the case of a monosaccharide, the spatial arrangement of the hydroxyl groups around the asymmetric carbon atom farthest from the carbonyl group decides its L or D notation. The spatial arrangement of the hydroxyl groups around this carbon is compared to that of the groups around the second carbon of the dextrorotatory isomer of glyceraldehyde. If the arrangements are found to be similar, as in the case of dextrose, the monosaccharide is assigned the D notation. That is why dextrose is named D+ glucose. Moreover, dextrose is dextrorotatory. This means that if a plane polarized light is passed through a solution of dextrose, the plane of the light will rotate towards the right. The plus sign in the name of dextrose indicates that it is dextrorotatory. Let's recap. Glucose is a monosaccharide with the molecular formula C6H12O6. Glucose is an aldohexose, that is, it has a chain of 6 carbon atoms and an aldehyde group in its molecules. The glucose we know as the most common and abundant sugar is a stereoisomer of glucose called D+ glucose or dextrose. The spatial arrangement of hydroxyl groups around the carbon of dextrose farthest from the carbonyl group is similar to the spatial arrangement of the groups around the second carbon of the dextrorotatory isomer of glyceraldehyde. Dextrose is dextrorotatory.